Alright, good afternoon and welcome to Master Toka online class. Today we'll talk about continuous function. Okay, they say that a function f is said to be continuous. Is said to be continuous, okay, in R, in a real number, okay, in a real number at a point x is equal to x naught, okay, if the following three conditions are satisfied. Okay, if the following three conditions are satisfied. Now, number one, the first condition is that normally f of that x, this, exists in R, exists in R, in a real number, okay? Number two, the limit equally exists. The limit of x tending to x naught of that f of x, okay, exists in R. Then finally, we will now see that f of x normally, okay, f of x naught must be equal to the what? That limit. So once these three things are satisfied, we conclude that that function is continuous. Let me give you an example of what we mean by that. They say determine the continuity. Determine the continuity of f of x, which is equal to 3x squared minus x at x is equal to 4. Solution. Now, the first thing you get is what? F of x is equal to what? 3x squared minus x. Now, f of 4 is equal to what? 3 into what? 4 squared minus 4, which is what? What do we have? What do we have? This is 16, right? This is 16. 16 times 3. Where did I keep my calculator? Okay, this is my calculator. Pardon me. So I have 16 times 3 to give you 48. So I have 48 minus 4, which is what? 44. Okay? We have gotten f of that 4. The next thing we're going to get is what? The limit of what? F of x as x tends to what? 4, which is what? The limit of that 3x squared minus x as x tends to 4, which is what? 3 into 4 squared minus 4, which is giving me 44. Now, the next thing we are checking out is what? That f of x naught is taken as what? The limit. Once they are now the same, okay, we now conclude that what? That f of x is continuous at where? At where? At x equal to 0. F of x is what? Continuous at x equal to 4. So that is that. Very simple. Okay, number 2. Number 2 said determine the continuity of f of x, which is equal to x squared minus 1 all over x plus 1, okay, at x equal to minus 1, okay. Solution. No, the main thing is to check if f of x is equal to the limit. So let's get the f of x first. F of what? That minus 1 is equal to, anywhere you see x, put minus 1, which is minus 1 all squared minus 1 all over 1 plus 1. So what do we have? Minus 1 squared is 1, and 1 minus 1 is 0. So I'm having 0 over 2, and 0 over 2 is 0. Okay? So the next thing we need to check is what? The limit of f of x as x tend to x naught. So what do we have? That is the limit of x squared minus 1 all over x plus 1 as x tend to minus 1. So which is now saying, so how do you get the limit? Factorize here. I'm going to have that this is the lim of this thing means x plus 1 and x minus 1 all over x minus 1 as x tend to minus 1. So what do we have now? Now, but obviously, oh sorry, this is minus 1. Sorry, this is minus 1, okay, which is 0 over 0. Sorry, this is 0 over 0. So which means f of x does not exist in R. 0 over 0 is what? Is undefined. So therefore, f of minus 1 does not exist. Since it doesn't exist, then you don't even need to start solving anything. Since it doesn't exist, you don't need to start solving anything again, okay? But for solving sake, I'm going to have the lim of x tending to minus 1 of this cancel this. I'm left with x plus 1, okay? So which is I'm saying now substitute minus 1 plus 1, which is what? 0. Okay, no, so here is plus, sorry, so I'm having minus 1, which is minus 2. So, and automatically this one is not even equal to this one, so the limit does not exist, okay? Sorry, it is not continuous at that point. So therefore, in fact, once you get that this one does not exist, just conclude that what? That the function this is not continuous at what? X equal to minus 1. Very, very important. You don't even need to do any other thing, okay? You don't need to do any other thing. So the next one we're going to talk about is further determination of continuity. Okay, they said let f be a function. Let f be a function broken into different parts. Broken into different parts, okay? And the part is that f of x is equal to that g of x is equal to g of x when x is less than x naught, okay? And is equal to h of x when x is equal to x naught, and is equal to y of x when x is greater than x naught, and is equal to t of x when x is not equal to x naught, okay? And the q of x when x is less than or equal to x naught, and r of x when x is less than or equal to x naught, okay? Now this is broken into different this spacing. Then I say here the condition or comparison or relationship between x and x naught determine the definition or value of f of x that should be used to verify the definition 3.1. Which definition are they talking about? The continuity, okay? To verify the continuity. So now what do we have? Now for a the first one, a said if f is equal to if x is equal to x naught, okay, if x is equal to f naught, then f of x is equal to what? H of x, right? Is equal to h of x. To verify the definition, we obtain that f of x f of x naught should be equal to this. Okay, for it to be continuous, we now say that f of x naught should be equal to what? H of x naught. Okay, number 2, that is when they are equal. Number 2 said if x now is less than x naught, okay, then f of x is equal to, where is less than? G of x. Okay, is equal to g of x. We use, okay, will be used to determine the definition, which says that the limit of f of x as x tends to this. However, in this case where x is less than x naught, implies that the left hand side, okay, limit of f of x should be equal to the right hand side. Okay, what do we mean? That whenever x is less than x naught, what we use to determine the continuity is that what? That the limit of what? F of x naught, f of x, sorry, as x tends to x naught must be equal to what? The lim of g of x as x tends to x naught. Okay, if they are equal, we just use the function. But if they are not equal, if it's less than, we use what? The limit. Okay, we use the limit. The same thing when they are not when they are greater than. So if x is greater than x naught, okay, then where is greater than, then our f of x is equal to what? Y of x. Okay, so we still use limits to verify this one. We still use limit to verify this one, that what? That the lim of f of x as x tends to x naught is equal to the lim of y of x as where? The lim of y of x as x tends to x naught. Okay, then if it is not equal to, if x is not equal to y, the next one, d, if x is not equal to x naught, okay, then our f of x where is not equal to, is equal to what? T of x. Okay, then how do we verify this one? We determine, it's used to determine that the limit of f of x is equal to this. We still use limit whenever they are not equal. We still use the limit, because in this one, these two now means that they are not, sorry, not equal. So it means that they are not equal. So if they are not equal, we still use limit. Okay, then if they are greater than or equal to, it's been determined by both the first one and the second one. Okay, if it is now less than or equal to or greater than equal to, we use this one and equally use this one. Let me explain what I mean by this. All these things I'm talking is story. Let's take a question. Determine the continuity of f at x equal to 2, okay, if f of x is equal to 12, okay, when x is less than 2, and is equal to 6x, okay, when x is equal to 2, and is equal to x plus 10 when what? X is greater than 2. Okay, so let us check that the solution. Here we have that what? Our x naught is equal to 2. Okay, for the first one, we told you that we use limit to check the first one. Okay, first of all, let's check the equality sign. Okay, that's what they gave us. F of x is equal to what? 6x. So therefore f of 2 should be equal to what? 6 bracket 2, which is equal to what? 12. Okay, and 12 is an element of what? A real number. Hence f of 2 exists in R. Okay, we have gotten the first one. Now the second one is by using limit. Don't forget, the second one is by using limit. So let us check for this one when it is less than. Okay, so you check that what? They say that it is 12 when x is less than 2. Okay, so let us check, which means our x naught is equal to what? 2 again. So we are using that the lim of f of x as x tends to what? 2, which is what? The lim of 12. The lim of what? The lim of 12 as x tends to what? 2, which is something as 12. Because we are not substituting anything. It's something as 12, and 12 is an element of a real number. So therefore the lim of f of x as x tends to 2 exists in where? Exists in R. We got the same answer, 12, and it still exists in R. Then the third one, we are still using lim. When x is greater than 2, we have a function that what? That f of x is equal to what? X plus 10. Okay? When this is this, we have that f of x is 12. So let us take lim here. The lim of x tending to 2 of what? F of x, which is what? The lim of x tending to 2 of x plus 10, which is simply 2 plus 10. 2 plus 10, which is what? 12. And 12 is an element of a real number. Okay? Therefore, the lim of x tending to x naught of f of x exists in where? Exists in R. Okay? Since it exists in R, and we got that all of them are equal. Okay? So what do we say? We further say that what? That it is f is continuous at this. So can I clean here? Okay. So since all of them exist in R, okay, since all of them exist in R, and they are equal, we now say that that f of x is what? Is continuous at, then f is continuous at f of x, and f of x is continuous at in R. Is continuous in R. Sorry. Is continuous in R. Okay. So that is that. Why did we say that is continuous? Because we got that what? That the lim of f of x is same thing as the lim of f of x. Is same thing as what? This. As x tends to x naught. Is same thing as this. Okay. So that is that. They must be equal for you to say that it exists. Okay, look at another example to clear it. I'm having that what? That f of x is equal to what? Is 13 when x is less than 2. But it is 6x when x is equal to 2. And it is x plus 10 when x is greater than 2. Okay? So the first one we are checking is equality. That f of x is equal to what? 6x. And we say when x is 2, so f of 2 is equal to what? 6 bracket 2, which is what? 12. And 12 is an element of what? R. So therefore, f of x exists in what? In R. Okay? Now number 2, we are using limit to check. The lim of what? The lim of 13. They say that f of x is what? 13. This one is when x is what? 2. That f of x is 13 when what? When s is less than 2. And we are using lim. So the lim of f of x as x tend to what? X naught, which is equal to what? In fact, this is which means x naught is 0. So this is the lim of 13 as x tend to what? 2, which is what? 13. And 13 is an element of real number. So the lim exists. The lim of f of x as x tend to what? X naught exists. So since it exists, then the last one, you check the limit again. But in fact, you don't even need to continue because f of x is not equal to the lim of this. So the limit does not exist. Since f of x is not equal to the lim of f of x as x tend to x naught, since it's not equal to, what do we say? That the function f is not continuous at x equal to 0. Okay? It's not continuous at x equal to 0. So that s equal to 2, sorry. We conclude that f is not continuous at x equal to what? 2. It's not continuous at that point. Okay. So that is for continuity. So when do we say it's not continuous? 1, when they are not equal. And 2, when any of these things does not exist in R. When it does not exist in R, so that is when we say that it is not continuous. Okay? And so the next thing we are going to talk about here is now undefined and discontinuity. Discontinuity and undefined. Discontinuity and undefined. Okay, discontinuity and undefined. Discontinuity and undefined. Okay, now if we say that okay, for any expression which is f of x over g of x, okay, now once they say that, okay, now f of x, if f of x is equal to 0, okay, for any expression this to be undefined, yes, for any expression this to be undefined, for it to be undefined, it simply means that the denominator g of x must be equal to 0. Okay, for it to be undefined, the denominator must be equal to the 0. But for any expression f of x all over g of x to be discontinuous or not continuous, to be discontinuous, okay, or not continuous, then the numerator f of x will be 0. Okay, so if you are talking about discontinuity, just say that the numerator is equal to 0. But if you are talking about undefined, just say that the denominator is equal to what? 0. So okay, then I say find the value of x. Find the value of x. Okay, find the value of x that makes y plus 2 all over y squared minus 3y minus 10 to be undefined, discontinuous. Okay, solution. Now the first one is talking about undefined. For something to be undefined means that the denominator will be 0. So we say that y squared minus 3y minus 10 is equal to 0. So let us factorize. I'm going to have y squared minus plus 2y minus 5y minus 10 is equal to 0. This is normal quadratic equation. So y bracket y minus 2 minus 5 is equal to 0. So what do we have? Sorry, y plus 2 here, plus 2 here. So what do I have now? Y plus 2 and y minus 5 is equal to 0. So therefore, y plus 2 is equal to 0, or y minus 5 is equal to 0. So therefore, y is equal to minus 2, or y is equal to what? 5. So therefore, the function this is what? Undefined at x is equal to, look at the statement, you say that what? The function y plus 2 all over y squared minus 3y minus 10 is what? Undefined at y is equal to what? Find the value of y, not the value of x. Jesus. Find the value of y. So it's undefined at what? X is equal to minus 2 or 5. Okay? So the next one is where? Number 2, For it not to be continuous, just say that the numerator is now 0. Okay? So therefore, y is equal to what? Minus 2. You now tell them the function y plus 2 all over y squared minus 3y minus 10 is not continuous at y equal to what? Minus 2. As simple as that. It's not continuous at y equal to minus 2. Okay? So that is that. And equally undefined at that point. I hope you know. So now, but if they say you should find the continuity, okay? All right, let's check. Let's find the continuity now. Okay, The next question said, at what point they can ask you, okay, at what point is the function f of x, which is equal to 3x minus 2 all over 4x squared plus 9x minus 9, okay, continuous. At what point is it continuous? Solution. Continuous. Okay. Now, and sometimes they will equally ask you, at what point does it exist? Okay. Now, before you talk about continuity, let's talk about the discontinuity. Now, we know that this thing will be discontinuous if 3x minus 2, which is the numerator, is equal to 0. So therefore, x is equal to what? 2 over 3. So the only point where this thing will be what? Discontinuous is that x equal to what? 2 over 3. That is the only point where this thing is what? Discontinuous. So therefore, you tell them the function f of x, which is equal to what? 3x minus 2 all over 4x squared plus 9x minus 9 is continuous at all real number except this set. Okay, it's continuous everywhere in R except when you remove this one, because this is the only point where this thing is not continuous. So it is all continuous in R except at this point. Okay, the same thing with define. At what point can this thing be defined? If you want to check the definition where it is what? Defined. Let's check where it is undefined. So this thing is undefined at 4x squared plus 9x minus 9 when it is equal to 0. So if the denominator is 0, we say that it is what? Undefined. So let us find the point where it is undefined. Which means we are finding what? We are finding our x. So this time this is giving me minus 36x squared. So let us share. Minus 36x squared 2 divide, minus 18x squared 2 divide, minus 9x squared 9 divide, minus x squared x minus x1. So I'm looking for, what am I looking for? The two things to replace it with. Okay, 3 can go first. 3 can go first. To have what? Minus 3x squared. 3 again minus x squared. X minus x1. So I'm having 4, 3 times 2 times 2, 4. 4 times 3, 12. 12 minus 3 is 9. So I'm having 4x squared plus 12x minus 9x minus 9 is 0. So I'm having 4x x plus 3. Am I correct? This minus 3, sorry. Plus 3. So x plus 3. So minus 3 is here, is equal to 0. So I'm having 4x minus 3 and x plus 3 is 0. So what do we have? 4x minus 3 is 0, or x plus 3 is 0. So therefore, x is equal to what? 3 over 4, or x is equal to minus 3. Now, we will now say that this function is defined everywhere in R except at these 2 points. So we say that the function f of x, which is equal to that thing, okay, the function f of x is what? Defined. Is defined at every real number except minus 3 and 3 over 4. Okay, please make sure you use this type of bracket. Don't use any other bracket except the set bracket, except any of these two. Okay, so that is that. I think I'm going to stop here. Thank you very much for watching. Please don't forget to subscribe and share it to anyone that needs it. God bless you.